I built an AI prompt router system. The goal is to intelligently router user queries to specialized AI personas instead of using one large prompt. I used a Python Grok API with a Llama model and a Docker for containerization. The problem I solved is improving response accuracy by detecting user intent first and then using a specialized prompt. A real world use case is AI assistants that can switch between coding help, writing feedback, and a career advice automatically. The system works in two steps: classify and respond. First, the user message goes to an intent classifier. It returns a JSON with the intent and a confidence. Then, based on the intent, the system selects a specific expert prompt like code, data, writing, or career. If the intent is unclear, the system asks a clarification question instead of guessing. This approach is better than a single prompt because each expert is focused and gives better responses. And this is my project structure. like uh, Classifier.py handles intent detection, and router.py handles routing and response generation, and prompts.py stores all expert prompts, and logger.py logs every request, and main.py is the entry point, and test messages.py is used for testing. Let's go briefly. The function in the classifier.py, this function sends the message to LLM and expects a JSON output. It If passing fails, it safely returns unclear intent. And Coming to router.py, this selects the correct expert prompt and generates the final response. If intent is unclear, it asks a clarification question. And coming to the prompts.py, these are the expert personas like a code expert, data analyst, writing coach, and a career advisor. The hardest part was making the classifier accurate. Initially, some inputs like write a poem were classified incorrectly. I improved this using better prompt engineering and adding examples. Another challenge was handling invalid JSON responses from the LLM. I solved it using try catch and fallback to unclear intent. The current system depends fully on LLM classification, so some edge cases may still be misclassified, and future improvements could include adding a rule-based pre-classification and using fine-tuned models and adding a web interface and improving confidence threshold handling. Okay, let's run it locally. Now I will run the application. How do I sort a list in Python? It detects the intent as a code and gives a programming response. Here you can see. In the second test, my writing sounds awkward. Now it routes to the writing coach and it gives a feedback. Yeah, you can see here intent of writing. And now third test unclear. Let's write hi. Since the intent is unclear, it asks a clarification question. And now I will run Docker. The application using Docker build. Okay, let's write Docker run env file dot env. Let's check what is a pivot table. The container runs successfully and generates a response. Yeah, here you can see the content is run successfully. The intent is data. Now Docker Compose are built. Docker Compose also works and runs the services. Here you can see Docker is running. Let's run one command like test messages dot py. The script tests multiple inputs, including edge cases. Yeah, here you can see unclear, writing, code, data, code, unclear, as the Docker is still running. So, yeah, I just completed. Yeah, it is built successfully. So finally, this project demonstrates intent-based prompt routing using LLMs. It improves accuracy by using specialized prompts and structured JSON outputs. Thank you.